Okay, so this week we want to look at lesson 7, solving linear systems by elimination. This is the third method that we can solve systems. So the first one we had looked at was graphing, and of course we did that graphing by hand this semester. We'll look at the graphing calculator next year. And we've also looked at substitution. And when we're looking at substitution, I just want to remind you that the method of substitution works really well when the coefficient is a plus or minus a 1. So that's what we were looking for there. And when we're looking at elimination, it works really well when the coefficients are the same, okay? The same coefficients. So not just a plus or minus 1 that we're looking for the same coefficients. And what we're going to do is we're going to end up adding and subtracting our two equations to eliminate one of the variables. So if we just pop down to question A, we've got 3x minus 5y equals negative 9 and 4x plus 5y equals 23. If I just write a little adding bar underneath there, this A is kind of in the middle here, in the way, and I want to add these equations. Now, if I add these up, I've got 3x plus 4x. I'm just going to add them in a vertical column. 3x plus 4x, so that's equal to 7x. And I know that negative 5y plus 5y, well, that's equal to 0 because those are opposite integers, the negative 5 and positive 5. And when you add opposite integers, you get a sum of 0. And then you've got your negative 9 plus 23, which is equal to 14. And of course, if you divide both sides by 7, we get x is 2. Now I want to go into either one of the first two equations. It doesn't matter which one. I'll choose number 1. I'm going to go 3 times 2 minus 5y equals negative 9, and I want to solve for y. So I've got 6 minus 5y is negative 9. When we move over this 6, we get a negative 6. We have a negative 5y equals a negative 15. I need to divide both sides by negative 5, and y is equal to positive 3. Okay, so I've got the x and I've got the y, and that gives me my full solution, which is 2, 3 in brackets with a comma in between. Now it also asks me to verify. I won't do them for every single question, but let's do it for the first one just as a good practice. If we verify our first question, we've got a 3x minus 5y equals negative 9. And just a reminder, we always want to go back to our original equation, okay? We don't want to use a manipulated equation because we could have made a mistake when we did the manipulation. So we want to always go back to the original equation when we do a check or a verify. And if I'm going to plug in a 2, let's just see here. I'm freezing up here already. Let's do this. So I'm going to put in a 2 for my x and a 3 for the y. And same with this side, a 2 and a 3. And we've got 3 times 2 minus 5 times 3 equals negative 9. Is that in fact true? 6 minus 15 is equal to negative 9. Sure it is. And just as a reminder, we need a left side equals a right side. Okay? And then on this side, we've got 4 times 2 minus 5 times 3 should be equal to 23. And that's 8 minus 15 should equal to 23. Oh, and that's a plus on our second equation. See, I'm just looking, I'm like, I've done something wrong. Of course I have. I forgot to put a plus here. Thank you, because I'm like, that's not adding up to 23. So that's a good way to do, right? Could have made a mistake there. So there's a 23 equals to 23. And our left side is equal to our right side. Okay, we're good to go. So that's how you do that one. And then with our next one here, oops, what's going on here? With our next question, I'm going to show you quickly. There's a negative and a negative, and we could in fact subtract those because we know that negative 2y minus negative 2y would be 0. Or if you rewrite that, negative 2y minus negative 2y, that's negative 2 plus 2, right? Negative 2y plus 2y, which is of course 0, right? 2 negatives make a positive. But that's a little bit cumbersome, and when you're subtracting, then you get way more negatives. So another trick that we can do here is we can make one of these negatives a positive. Well, how do we do that? Choose one randomly, doesn't matter which one, and we're going to multiply that equation through by -1. I'll just choose my second one just for, I have to choose one. Okay, so I'm going to rewrite my first equation down here. Okay, just 2x minus 2y equals 10. And the second equation, okay, the second equation, what we're going to do, we're going to multiply it through by a -1, and we get a -3x plus 2y equals -5. Now what this allows me to do, I still have a few more negatives, but I'm adding the equations now instead of subtracting. And I do believe that you probably agree that it's easier to add integers regardless of their signs than it is to subtract. Okay, so now I've got a 2x plus a -3x, which is a -x, that's a -1x. The -2y and the +2y, those cancel, and we're left with a +5. 10 plus -5 is 5. And then I'm really wanting not -x, but I'm wanting to solve for x, so we divide both sides by -1, and we get x is -5. Now I'm going to plug that into one of the equations, just for, I've got to make a choice. I'm going to choose the first one. 2 times -5 minus 2y equals 10. See, I'm going back to my original equation, and I've got a -10 minus 2y. I'm just solving. And when we move over this, we get a +10. -2y is 20. Dividing both sides through, we get y is -10. Okay, so our answer here, our solution is -5, comma, -10. And of course, you could go through and do a verify, and we will do those. And at times, you're gonna have to hand those in. Okay, so absolutely critical to know how to do those, but I think you probably get the idea over here. Okay, when we did this check. Okay, we checked both of those equations. Check, check. The next one, solved by elimination, it's a try. You can pause the video. I can give you the answers, but you can try it yourself if you would like. I think that's a good idea. Why don't you try that? Okay, so hopefully you got the same answers I did. I got a 1, 1, and you can try verifying your equation as well. Let's look at the next example. It says solve the following system and verify your answer. So here's our system. It's a little bit wonky the way this is written. So that's your first equation. Just trying to break this down a little bit. And there's your second equation. Okay, so they're written really close together there. But it says solve by eliminating x for A, and then B says solve by eliminating y. So in fact, you could use either variable. By eliminating either variable, you could solve this equation. So let's look at if we wanted to eliminate the x variable. This is an x coefficient of 2, and the coefficient for the second equation is 4. So of course, if I want to make those the same, I could multiply this by 2. Okay, and then what I do to one side, I do to the other. So our first equation would become 4x plus 6y is equal to 8. And our second equation is still, of course, 4x minus y equals 22. Okay? Now, if I wanted to eliminate the x's there, I would subtract. Right? We're going to subtract our variables. I'm going to put a minus sign in front. 4x minus 4x, well, that would be 0, right? 4 minus 4. And then 6y minus -y, that would be a 7y. Okay? 6 minus -1 is 7. And then 8 minus 22, that's a -14. Dividing both sides by 7, we get y is equal to -2. Okay, so that's one way. And then, of course, we could go back to either equation and solve for x. But because they want us to solve by eliminating y for question B, we're going to solve for x. So if I want to eliminate the y's, how would I make the y coefficients the same? This one's a 3, this one's a -1. So of course we can multiply this equation by 3. And if we do that, I'm just going to rewrite my first equation, which is 2x plus 3y equals 4. And our second equation, multiply through everything by 3, we get a 12x minus 3y equals 66. So now when I add those two guys, positive 3y minus 3y, there's our 0, and we get 14x equals 70. Divide both sides by 14, and we get x is equal to 5. And there's our solution. our overall solution is 5, -2. Okay, if we look at the next question, it says solve by elimination, verify your solution. So this is an example of you have a choice. Do we want to get rid of the x's and make those x coefficients the same? Or would we like to get rid of the y's and make the y coefficients the same? Doesn't matter which one. If I were to eliminate the x's, I would multiply this by equation by 4 and this one by 3 to make them both a 12, right? It's like looking at your lowest common multiple. Like your lowest common denominator, it's the lowest common multiple, okay? Or if we wanted to get rid of the y's, I would multiply this one by 5 and this one by 2. So choose your weapon, whichever you'd like to do. Let's eliminate the y's just for fun. I'm going to multiply everything through by 5, and if that's the case, I'm going to get rid of this so I don't get confused. And when we multiply everything through by 5, we get 15x plus 10y equals 10. So we're multiplying through everything by 5. If we're going to multiply everything on the bottom by 2, we end up with 8x plus 10y equals, this is a 2 here, 24. Okay, and now we don't always subtract, but I could subtract here. There's no big negatives to worry about. 10y minus 10y is 0. 15 minus 8, that's 7x, equals -14. So x is going to equal to -2. And then we would go back and plug in our x into either equation. Let's just choose the first one for fun. 3 times -2 plus 2y should equal to 2. That's a -6. Plus 2y equals -2. And then, of course, we move that over. We get 2y is equal to 4. And divide by 2, y is equal to 2. So our final equation, or final solution rather, is -2, 2. I just want to alert you to a couple. I don't have a big assignment suggestion. I think for your assignment you could do number 1, ACE, and I think I thought 2A and 3A and number 4. So that's 6 questions, pretty doable. There's a couple questions that look like this, or they're not lined up. Things are not lined up. So if you have something like this, I just want to get you set up. You would take this equation number 1 and you would rewrite this as 2x plus 2y equals -2 minus 4x. And then I want to move everything over and I want to line up my variables and my constant term. So my -4x, that of course comes over, bloop. He's going to become 6x plus 2y equals -2. So there's our first equation, manipulated around a little bit. And then let's do the same thing with our second equation. I just want to take this 3x, move that over. So then I'm going to get, let's rewrite this, 14x minus 3x. I've got the plus 27 here, and that's going to equal to y. I also want to move the y over and move the 27 to the right. So I would have 14x minus 3x, which would be 11x minus y equals -27. So here would be our second equation ready to go. Okay, so you could work through the rest of that, but the idea is we want to line everything up in columns, right? I would write this under here, minus y equals -27. There's our second equation manipulated. Okay, I can't eliminate yet. I would have to multiply all of the coefficients through by either a 2 or this by 11 and this by 6, whichever. Choose your method. Okay, here's your assignment, and for the first password word for this week is almost. It would help if I could spell almost. Okay, thank you, and as always, if you have any questions or concerns, please do not hesitate to contact me.